we're going to talk about 1-wire, 2-wire, 3-wire, and 4-wire sensors. And I'm going to draw them out so you get an idea how this works. So the first thing to understand is inside the ECM, whether it's a 1-wire, 2-wire, 3-wire, or 4-wire sensor, they're all going to share something in common. That's going to be the 12-volt feed input. That 12-volt feed input will then go to a 5-volt regulator. So we've got our 5-volt regulator, and then what I'm going to do is I'm going to come down here and we're going to feed that 5 volts off the sensors. It may not be just like this, but this is just for a quick explanation. So if I steal off of that, I'm going to make the ECM go a little further out here. 1-wire sensor, 1 wire. So we're going to have a fixed resistor here. And I'll make it a little bigger so maybe you can see. Maybe. Then that wire will go out. It will go to a device, which is basically a sender, but it's a sensor. And it will thread into the exhaust riser. And the other side of that obviously is block ground. That sensor is a switch. And that switch is normally open until it gets hot. So if it gets too hot, the exhaust temperature goes up, then the switch will close. So if the temperature goes up to the point, the switch will then close. What that will do is that will then give a path for current to ground. Now, I'm going to have here inside the ECM an AD converter. And an AD converter is simply a voltmeter that the ECM is looking at the voltage on that wire. So on one side of the AD converter, I have the voltage on the wire, and the other side, I have a ground. So that indicates that the ECM, what is the voltage on that wire? In normal operation, that circuit is open, then it would read 5 volts. So 5 volts would go through the fixed resistor, and it would end at the open circuit in the sensor. So I'd have 5 volts in the sensor, and I'd have 5 volts all the way through. This would read 5 volts. When the sensor closes, when it gets too hot, now you have 5 volts on one side of a fixed resistor and you have ground on the other. That means this resistor is going to use up all the voltage. There will then be 0 volts on that circuit, and the voltage went from 5 volts, I can draw it right, to 0 volts. And that is a fault code, high exhaust gas temperature and alarm. So that's the simplest sensor circuit. That's a 1-wire sensor. Okay? 2-wire sensor is a little more complicated. We then have a fixed resistor inside the ECM, and then we have a variable resistor inside the sensor itself. And we also have a path back to the ECM, which is going to go to ground. This is a variable resistor. This is the coolant temperature sensor, engine coolant temperature, or intake air temperature, something like that. These are thermistors, all right? So a thermistor is a 2-wire sensor. All 2-wire sensors are thermistors, temperature related. Now in this case, I have 5 volts goes into the fixed resistor, and I have less than 5 volts goes to the variable resistor, and the variable resistor, because it can change resistance, is going to change the voltage on this wire. Inside the ECM, there is an AD converter that is monitoring that wire inside the ECM, okay? So I'm going to draw the wire or the ECM here, And this is the inside of the ECM, that's the outside of the ECM. So the 80 converter is inside the ECM, the 80 converter on the one wire is inside the ECM. So I'm looking at the voltage on that wire. If I increase resistance here, this fixed resistor stays the same and the voltage will drop. All of your temperature sensors, thermistors, are called NTC thermistors, negative temperature coefficient thermistor. That means if the temperature of the sensor goes up, the resistance of the sensor goes down. If the resistance of the sensor is increasing, all right, then the temperature of the sensor is decreasing. If this resistance is decreasing, the temperature is increasing, then this is going to use up less voltage, this is going to use up more voltage, and then there's going to be less voltage here. So the voltage that you see on the scan tool will go down, and vice versa for a thermistor. So if temperature goes up, the internal resistance of the sensor goes down. This uses less voltage, this uses more voltage, because you have to use the whole voltage potential up between the two. It's a series circuit, okay? Then you have your path to ground. That's a 2-wire sensor.